This question is about a fusion reaction between two carbon nuclei. If you see that, you might panic and think we haven't been taught about fusion reactions between carbon nuclei. But it doesn't matter that you haven't met it before, because all we've got to do is just keep track of all the particles, keep track of all the protons and the neutrons. So if we have a look at the left-hand side, to begin with, we've got 6 protons in each nucleus, so 12 protons altogether. After the reaction occurs, what we've got? Well, we've got a helium nucleus with 2 protons, but we started with 12 protons. So where are the other 10? Well, the other 10 must be in X, so X must have 10 protons. And we also know that, to begin with, the total number of protons and neutrons, 12 plus 12, was 24. Afterwards, there are 3 of them in the helium nucleus, which means there's 21 protons and neutrons, not accounted for, so X must have a total of 21 protons and neutrons. And we know it's got 10 protons, so that must mean it's got 11 neutrons. Part B. 2 of these carbon-12 nuclei may also undergo a fusion reaction that produces other isotopes of X and helium. State what's meant by the term isotopes. We should know what it means. So when you're stating it, be really clear about it. Make sure that you do mention the fact that isotopes are atoms that have got the same number of protons but different number of neutrons. Don't leave it for the examiner to guess. Don't say things like the same sort of atom. Be clear. Make sure you mention same number of protons, different numbers of neutrons. Part C. Calculate the ratio of charge to mass for the helium nucleus. Helium with a proton number of 2, nucleon number of 3. We've got to remember, charge to mass ratio is always given in coulombs per kilogram. So we don't just look at those numbers, we think about what these numbers actually are in terms of the real units for charge and for mass. So let's work it out. The charge, now it is a nucleus, it's not an atom, it's a nucleus. So what are the charged particles? Well, there are 2 protons. So the charge will equal 2 lots of the charge on a proton. And the charge on a proton, could look it up on the data sheet if we needed to, it's the same as the charge on an electron, except it's positive. And the charge on an electron is on the data sheet 1.60 times 10 to the minus 19 coulombs, which gives us total charge for the nucleus. 2 times 1.6 is 3.20 times 10 to the minus 19 coulombs. The mass, well, inside the nucleus we've got the 2 protons and 1 neutron. So using the data sheet, 2 protons, look on the data sheet, mass of a proton rest mass 1.673 times 10 to the minus 27. Plus, well, the total of 3 there must mean that there's 1 neutron, so 1 times, because I don't need to bother writing 1 times, I'll put it there, make it clear. The mass of a neutron, 1.675 times 10 to the minus 27. Kilograms, so that gives us a total of 5.02 times 10 to the minus 27 kilograms. So the ratio charge over mass (3.20 times 10 to the minus 19 divided by 5.02 times 10 to the minus 27, 6.37 times 10 to the 7 coulombs per kilogram.